Hello everyone, I'll be presenting the walkthrough of the technical drawing course. It is a part of the communication and computation design track. In this course, students will learn the principles of descriptive geometry, including the orthographic projections, axonometric, auxiliary, intersections, in addition to shades and shadows. And at the end of this course, students will be able to apply these principles through a study and technical representation of architectural projects. Course outline and CLOs. Regarding the fact that this course is a practical course, it requires a lot of assignments. So for every lecture, it was followed by an assignment, whether during the session or taken as a home assignment.
Sarah?
Yes.
Sarah, sorry. Okay, no, go ahead. My screen was frozen at the first slide.
Okay.
Sorry for the interruption.
It's okay. هلا أنا بعرض my outline. ما بعرف إذا مبين.
Yes, we can see it.
Yes.
Okay. And so for each assignment, there were assigned for them certain CLOs. There are 8 CLOs for this course, mapping 3 NAB criteria, which are professional communication skills, design thinking skills, and ordering systems. These CLOs are starting with the first CLO is to draw accurate, neat, and balanced measurable drawings, understand and apply the principles of technical lettering, draw and read 3D geometries, objects through their 2D orthographic projections, and vice versa, resolve intersections of complex geometries, objects, build physical models of objects with oblique intersecting planes, understand the principles of shades and shadows, analyze architecture design through drawings and physical models, and finally represent graphically the central characteristics of an architectural project. Course structure. The number of lectures given in this course was 25, and there was 17 assignments, and there was 1 project and 2 exams. Sorry?
ده الإيكو تبعك.
Okay. Regarding the learning pyramid, I usually start the session with 40 to 45-minute lecture, and it was followed by a demonstration of what I explain in this lecture. And I usually use the AutoCAD platform to explain a certain application. And after finishing this demonstration, I ask the students to do the same exercise or give them a similar exercise to make sure that they understand what have I explained. And this lies under the practice by doing. Matching grading assessments to CLOs. This table shows the CLOs of each assignment and exams and the project. And we realized that the 2 most targeted CLOs were the first CLO, which is draw accurate, neat, and balanced measurable drawings, and the third one, which was how to draw and read 3D geometries through their 2D orthographic projections and vice versa. Regarding the assessment, it was assigned 40% for the assignments and 30% for the exams, 15% for each, and 25% for the project and 5% participation. Grades report, assessing students' performance in CLOs. This table gives us the CLO average for each student. If you take example, we see the CLO 1. For each student, I placed all the assignments, all the projects, and the exam that include this CLO to calculate the CLO average for every student to obtain at the end this graph. This graph shows for each CLO, the grades of the students. So if we take an example of CLO number 4, we can see that the highest grade here is taken 94, and to see the student, it is colored in pink. We see here Hiba Kilani gained the highest grade in this CLO. This is an example. And we can read the student performance per CLO as well in another perspective. We can see here for each student, his grades regarding the CLO. If we take an example, Milad Antoine, we can see here that the highest grade was taken 89, and if we see to which CLO, it is CLO number 6, and etc. Class average by CLOs. This graph shows the highest grade obtained for each CLO and the lowest grade in green and the class average. We can also realize that the class average for every CLOs are almost 70, sometimes above, sometimes below, but the range was around 70, the average of the all CLOs. Students' performance diagram. This graph shows us the average grade for every student during all the semester. And the graph to the right shows the grades of each assessment for each student. If we take an example, Milad Anton, we can see that he did well in the exam 1, exam 2, and the assignments, but did not do very well in the project. And if we take another example, we will find the different, of course, assessments. Class average diagram. In this diagram, we realized that the student did well in the assignments, or did better in the assignments and the project, but did not do very well in the exams, since they took the average grade was around 61 and 65. Attendance report. In general, the attendance was very high in this course. If you can see this table, here are the name of the students, and these are the percentage of attendance. We can see that it is the percentage is around or between 80 to 90%. And of course, there are always exceptions. Plus, these two students that did not have high attendance, they actually failed the course at the end. And this graph shows us the number of attendees during the sessions. The number of students in this course was 19. So we can see that the average number of attendees was between 17 and 18. Course stages covered along the course timeline. The course is structured into 5 distinct sections. The first section is the culture of drafting, where student learns how to use the tools of drafting, how to draw accurate and balanced measurable drawings. And the second section is projection systems, where students learn the orthographic projections, axonometric, auxiliary. And the third section is the intersections. In this section, the complexity gradually increases from planar to two-dimensional curved solids. And the fourth section is shades and shadows, where students learn how to apply shades and shadows in multi-view drawings and axonometric drawings. And finally, application architecture, where students choose an architectural project and represent graphically its characteristics of the project. Specimen of students' work. If we start by the first section, which is the culture of drafting, this is an example of drawing in ink of geometric forms, and this is another sample showing the application of technical lettering. And if we take another samples of the projection systems section, here we can see sometimes I give them a 3D object and they need to draw its multi-view drawings. And vice versa, I give them the multi-view drawings of a solid object and they need to draw its 3D. And they learn how to draw the circle in axonometric projection. And of course, they learn the oblique projections. And the auxiliary views, I give them a solid object with a random plane, and they need to find the normal view of a random plane with the use of certain techniques. And the intersections section, I started by giving first a simple assignment, which is the intersection of two planes, then intersection of a solid with a random plane, and they made a model of it, reaching the interpenetration of two solids. The fourth section is the shades and shadows. These are samples of how they applied these shades and shadows in multi-view drawings and in axonometric view. Application architecture. In this project, they learned how to show the characteristics of a certain project through drawings and different types of diagrams. They like functional diagram, circulation diagram, and exploded axonometric. In addition, they learned how to do a conceptual model and a presentation model. And this is another example. I chose each project to have definite or certain characteristics. In this project, I chose to make to let them do the model of scale 1/50 to show more details. And this last project, where if we can see this model, this is surrounded by two buildings. If we remove this building, we can see what's inside this building. Instructor reflections and recommendations. Considering that this course is a practical course that requires regular follow-up on students' work and assignments, the number of students was high for one instructor. Actually, we began with 25 students, however, 3 left the university and the other 3 dropped the course. So we ended up with 19 students, but still it was a high number because it was a bit time-consuming to follow up on all students and to correct the assignments. So I believe that it was a big number for one instructor. The second point is that the cost of the tools and materials required for model making was high, which affected on the quality of deliverables. Actually, I think that most of them used the foam board, which I do not very much prefer, but it was, I guess, the most affordable material to use. And the only part of the section of shades and shadows that I could not cover due to shortage of time was how to apply it in architecture. They already knew how to do shades and shadows in multi-view drawings and axonometric, but there was not enough time to show them how to be applied in architecture. However, as a solution, I think it can be offered in the coming course, which is the architectural communication course that they would be taking in the spring semester. Regarding the outline deviation or the assessment, there were 3 exams that were planned to be given, but 2 exams were executed because of the lockdown. So I did an additional phase to the project, which was the conceptual model. They did it, and the assessment percentage changed according to this. And the last point is, I believe that we can dedicate more sessions to the intersection sections. I dedicated 4 sessions. I believe that if it was given 5 sessions instead of 4, they would have mastered this section more. Thank you.